Welcome to the Deep Dive. This is where we take the sources you send us and, well, we dive deep to pull out the key knowledge.
Exactly. And today, we've got a pretty technical one. It's an NI 43-101 report.
So, the mission today. Figure out what this report actually says about lithium potential up there in Alberta. We're talking geology, extraction, the whole picture, really.
And now you having to read, hundreds of pages of technical jargon.
Let's start with the basics. Where exactly is this Peace River project?
Okay, so we're looking at northwest Alberta. It's a big chunk of land situated roughly between the town of Peace River and Grand Prairie.
Big chunk. How big are we talking?
We're talking 62 contiguous permits, metallic and industrial mineral permits specifically. It adds up to nearly 500,000 hectares.
Wow.
Right, 100% Neolithica.
And geologically, what's special about this spot?
Well, this whole area sits right over the Leduc Reef carbonates, part of the Woodbend group. These are old, Devonian reef structures, deep underground.
Okay, ancient reefs. And is it remote, or is there infrastructure nearby?
That's a good point. It's actually reasonably close to communities like Grand Prairie and Peace River and the associated infrastructure. That could be important later on.
Alberta means oil and gas, though. How does that fit in? Do the areas overlap?
They do, yeah. Existing oil and gas leases coexist with these mineral permits. It's layered.
So how does that work legally? Especially with lithium being in brine, not a traditional mineral ore.
Well, Alberta's actually put new regulations in place specifically for brine-hosted minerals.
Oh.
And Neolithica has the right under these regs to convert their existing permits to focus specifically on these brine minerals. They have until the end of this year, actually.
Giving them the clear right to go after lithium in that brine. Makes sense.
Yeah, and of course, if they get to production, they'll be paying royalties to the Alberta government, like any resource project.
Standard procedure. Okay, so the regulatory side seems to be adapting. Let's dig deeper into the geology you mentioned. Why these Leduc reefs?
Right, so the project area is positioned along the eastern edge of what geologists call the Peace River Arch. This was a huge geological feature back in the Devonian period.
A feature that influenced how rocks were formed.
Exactly. During the Upper Devonian, that's the Frasnian age, technically this whole region was like a shallow inland sea, and it was bounded by this Peace River Arch on one side and the West Alberta Ridge on the other.
And the Leduc Formation reefs grew in that sea.
Precisely. They form these thick reef complexes, sometimes up to 300 meters thick, massive structures.
And you said they're carbonates, like limestone.
Originally, yes. But a key process happened later, dolomitization. A lot of that limestone got altered to dolomite.
Okay. And why is dolomitization important here?
It's really important because that process tends to increase the porosity and permeability of the rock.
It creates more tiny spaces and connections.
You got it. Like turning dense limestone into more of a rocky sponge. It allows fluids, potentially lithium-rich brines, to be stored and to move through the rock.
So a potentially good reservoir rock. What about the bigger picture, the structure of the area over time?
Well, the region wasn't static. There was block faulting, big shifts in the Earth's crust. And later, that whole Peace River Arch actually collapsed, forming what's called the Peace River Embayment.
Okay, sounds dramatic. How did that affect things?
These major geological events definitely influenced where sediments like the Leduc reefs ended up, and probably created pathways for fluids to migrate through the subsurface over millions of years.
Interesting. And what about the layers directly above and below this Leduc reef sponge?
Good question. Above it, you generally have the Ireton Formation. It's mostly considered an aquitard, meaning it doesn't let fluids pass through easily.
Like a seal?
Sort of, yeah. Although the report notes that in this specific area, the Ireton actually contains quite a bit of reefal debris, material eroded from the Leduc itself, which might complicate that simple seal picture a bit.
And underneath the Leduc?
Underneath lies the Beaver Hill Lake group. And what's interesting there is that formation waters in the Beaver Hill Lake group are already known elsewhere in Alberta to contain lithium.
So a potential source rock below and a potential reservoir in the Leduc. Okay, that paints a picture. Now, the crucial part, the lithium itself. What's the actual evidence for it being in the Leduc Formation here?
The report pulls data from government sources, the Alberta Energy Regulator, the Alberta Geological Survey, Historical data.
Stuff likely collected during oil and gas exploration over the years.
Probably a lot of it, yes. And this data shows lithium present in formation waters across Alberta, including specifically in the Leduc Formation near this project area.
Okay, it's known to be there. What kind of concentrations are we talking about?
The measurements reported from wells right next to the resource area show lithium ranging from 40 milligrams per liter MgL up to 100 milligel.
Quite a range.
It is. The average concentration calculated from that data is 72 milligel. For the resource estimate itself, the report uses a representative grade of 70 milligel.
Which seems like a reasonable, maybe slightly cautious number based on that average.
I'd agree. Seems prudent for this stage.
Okay, 70 milligel. But where did the lithium actually come from? How did it get concentrated in these brines?
That's still a bit theoretical, but the report discusses some possibilities. One idea involves hydrothermal fluids.
Hot water moving through the rock.
Essentially, yes. Possibly linked to that dolomitization process we talked about, maybe after the Peace River Arch collapsed. These hot, mineral-carrying fluids could have moved up faults and fractures.
And brought lithium with them. Where from?
Theories suggest maybe from deep Precambrian basement rocks underneath everything else, or perhaps from the migration of very old, deep brines associated with the Prairie Evaporate Formation.
Yeah.
It's complex fluid migration over geological time.
Fascinating possibility. So we've got the location, the sponge rock, the evidence for lithium at decent grades. How do they bundle all that into a resource estimate? You mentioned NI 43101.
Right. That designation is key. It's a Canadian standard for reporting mineral resource information to the public. It ensures specific guidelines are followed.
And the type of resource they've estimated here is?
It's classified as an inferred mineral resource.
Inferred. What does that mean in practical terms?
Inferred is the category with the lowest level of geological confidence. It means, based on the geological evidence and some limited sampling, you can imply that the mineralization is there and has some continuity, but you haven't definitively proven it yet.
So it suggests potential, but needs more work to confirm.
Exactly. It's an initial estimate, often the first step.
Okay. How do they actually calculate that inferred number? What was the method?
It was a multi-step process. First, mapping the geology, basically creating 3D surfaces for the top and bottom of the Leduc Formation aquifer.
Defining the container, essentially.
Right. Then estimating the net torus interval, how much of that rock thickness can actually hold fluid. From that, they calculate the total aquifer volume.
But not all that volume contains lithium brine, right? You mentioned oil and gas.
Correct. They had to account for and subtract the volume estimated to be filled with hydrocarbons and also any volume where water might have been injected over the years for oil production purposes.
Okay, so they get a volume of brine. Then what?
Then they apply that representative lithium grade, the 70 milligel, to that calculated brine volume.
And the report mentions a specific formula.
Yeah, they call it the LRM, or lithium resource mass calculation. It basically boils down to resource area, X effective porous thickness, X average porosity. That gives you a rock volume. Adjust for fluid saturation, subtract the oil and injected water volumes, and multiply the remaining brine volume by the lithium concentration.
Got it. So running those numbers, what's the final inferred resource estimate?
The report estimates 2 million tons of elemental lithium.
2 million tons. How much brine is that?
That's estimated to be contained within about 33 cubic kilometers of formation brine, assuming that 70 milligel average concentration holds true.
That sounds like a lot of lithium. And they often talk about LCE, lithium carbonate equivalent.
They do. Using the standard industry conversion factor of 5.323, that 2 million tons of elemental lithium works out to 10 million tons of LCE.
10 million tons LCE. Still an inferred resource.
Yeah.
But significant potential.
Definitely significant potential. And they do note that further exploration could potentially upgrade parts of this resource to higher confidence categories, like indicated or measured.
And they used a cutoff grade, like a minimum concentration.
Yes, 50 milligel lithium was used as the cutoff. Below that, it wasn't included in the resource. They argue that 50 milligel is a reasonable economic threshold for a brine project.
Right, because you're dealing with pumping fluids. The economics are different than hard rock mining.
Exactly. Processing costs are key.
Okay, so potentially a lot of lithium down there. How would they actually get it out? Solar evaporation ponds, like in South America, are probably out, right? Too cold?
Absolutely not viable in Alberta's climate. This is where direct lithium extraction, or DLE, technology comes in. And Neolithica has a joint venture partner for this, IAP Resources.
DLE. We hear that term a lot now. What kind of DLE are they looking at?
IAP uses an ion exchange sorbent technology. Think of it as a highly specialized filter or sponge.
A sponge that grabs lithium.
Pretty much. It's a material designed to selectively pull lithium ions out of the brine as it flows past, while letting most of the other dissolved stuff, sodium, calcium, magnesium, etc., go through.
And has this LiEP technology been tested on similar brines?
Yes, the report states it's been tested on brines from Western Canada with similar chemistry. The results apparently showed good performance, fast reaction times, high selectivity for lithium, and importantly, a long lifespan for the sorbent material itself.
Can you explain the basic idea of ion exchange a bit more simply?
Sure. Imagine the sorbent has specific docking sites, chemically designed to attract and hold on to lithium ions. When the brine flows through or over the sorbent, the lithium ions dock onto these sites.
Leaving the other ions behind in the water.
Mostly, yes. That's the selectivity part. Then you wash the sorbent with another solution, usually an acid, which releases the captured lithium, creating a much more concentrated lithium solution that can then be purified further into battery-grade chemicals.
Okay, that makes sense. Does the report say anything special about LiEP's specific sorbent?
It highlights a few things. They mention LiEP's tech is a proprietary molecular sieve that shows high stability, particularly in acidic conditions used for stripping the lithium off. It also claims good performance over many cycles, up to 1,400 cycles in lab tests, and faster kinetics and better selectivity than some competing DLE methods.
Sounds promising on paper. What's the next step for proving it out?
They're planning a pilot-scale demonstration plant. The goal there is to really dial in the optimal operating conditions and confirm the performance at a larger scale before committing to a full commercial plant.
Right, scaling up from the lab.
Yeah.
Okay, interesting tech. But what about the environmental side of things? Pumping large volumes of brine.
Yeah, the report is upfront that specific environmental studies for this project haven't been done yet. That's typical for this early stage.
But they anticipate needing to follow existing regulations.
Oh, definitely. They mention Alberta's Environmental Protection and Enhancement Act, the Water Act. All the standard provincial environmental laws would apply.
What are the main potential environmental risks with this kind of brine extraction?
The biggest concern is usually the potential for accidental spills of the brine at the surface. It's very salty water, often containing other elements, so you wouldn't want it getting into freshwater systems or onto sensitive land.
So standard containment and monitoring needed.
Yes, the report anticipates using procedures similar to what the oil and gas industry already employs for handling saline water. Things like pipeline integrity monitoring, secondary containment around facilities, and emergency response plans.
And getting permits for the wells needed to pump the brine out and maybe inject spent brine back down.
That process would likely go through the Alberta Energy Regulator, the AER, similar to oil and gas wells. That typically involves stakeholder consultation, environmental screening, and planning for potential hazards like H2S, hydrogen sulfide gas, which can sometimes be present.
Okay. And shifting to the social side, what about community impact?
The report frames the potential social and community impact as largely positive.
How so?
Well, the argument is that it leverages the existing oil and gas infrastructure and, importantly, the skilled workforce already in the region. It offers a way to diversify the local economy beyond traditional oil and gas.
Tapping into that energy expertise for a new energy metal.
Kind of, yeah. Plus potential jobs, economic activity. Of course, they also state they'll need to consult with Indigenous communities as the project progresses.
And unlike a mine, you don't have a big hole to fill at the end.
Right. Since it's all done through wells, a typical mine closure plan isn't expected. Reclamation would focus on the surface facilities and well sites, similar again to oil and gas.
Makes sense. Now, no project is without risks, especially early on. What challenges does the report flag?
Well, there are the general risks of any exploration project. The geology might not be exactly as interpreted, the grades might vary, the extraction tech might hit snags at scale.
Sure, standard stuff. Anything specific to this project?
One thing they mention is the initial reliance on using existing oil and gas wells to get brine samples for testing.
Access agreements could change? Well, the wells might not be ideal.
Potentially, yeah. So as a mitigation, they note they could drill their own dedicated wells, specifically designed for brine production and monitoring, or even look at acquiring suitable existing wells if needed.
Okay, they have backup plans. So what are the concrete next steps Neolithica has planned?
They've laid out a two-phase approach for moving forward.
Phase 1 being?
Phase 1 is really focused on that DLE technology, building and running the pilot plant to prove out the extraction and refining process. They estimate the cost for that at around $1.5 million.
Getting the technology right first. And Phase 2?
Phase 2 goes back to the geology. It involves more detailed hydrogeological work on the Leduc aquifer itself.
Like what?
Things like refining the geological mapping, analyzing more digital well-logged data, maybe conducting pump tests to really understand how easily the brine can flow through the formation over larger distances.
And the goal of Phase 2 would be
to get a much better handle on the aquifer's properties and, ideally, to upgrade that inferred resource estimate to indicated or measured categories, which represent higher levels of confidence.
Right, de-risking the resource itself. Okay, so let's try and pull this all together. We've covered a lot of ground from this report.
We have. I think the main takeaway, for me at least, is that this technical report clearly outlines a significant potential lithium resource, albeit inferred at this stage, hosted in deep brines within the Peace River area.
Right, located in those porous Leduc formation reefs we talked about.
And importantly, it pairs that resource potential with a plausible extraction method, direct lithium extraction, using light-peace sorbent technology that seems suited to the Canadian context.
Yeah, the aha moment here feels like the intersection of things, using decades of oil and gas data, applying modern geological understanding, and bringing in these new DLE technologies.
It really could unlock a whole new type of resource development in a region already skilled in subsurface energy extraction.
Definitely. But we absolutely have to stress that word potential. It's an inferred resource. There's still significant work and investment needed to confirm the grades, the aquifer productivity, and the extraction economics at scale.
Absolutely critical caveat. This report is a snapshot in time, an early-stage assessment.
So maybe the final thought to leave with you, the listener, is this. Considering the skyrocketing demand for lithium globally, mostly for batteries, and considering Alberta's established energy infrastructure, what could a successful lithium brine industry actually mean for that region?
Yeah, what are the real economic diversification prospects? And looking further out, what deeper questions should we be asking about the long-term environmental footprint and sustainability of extracting lithium this way compared to other methods? Definitely something to keep an eye on.